Hello everyone. All right, lesson 2 is more vocab. So we're going to jump right in. I'm going to do the words first, then the picture and notation. A figure formed by two rays with a common endpoint, that is an angle. Because if I have a ray that looks like this, and a ray that looks like this, those are two rays connected at this common endpoint, and that forms an angle. Now, when we name an angle, we typically name an angle with 3 points. So here are my 3 points, A, B, C. The end point that separates your two rays is always going to be the letter in the middle. That's called the vertex of your angle, which we'll get to that in the next definition actually. But this could be named angle A, B, C, or angle CBA. Now, sometimes you will be allowed to label your angle just by the vertex. But there's situations where that won't be acceptable, and I'll explain that in future lessons. And then sometimes you may see a number on the inside of your angle that does not have a degree symbol. That is also the name of your angle, so you could also say this is angle 2. Now, when we are talking about the measure of our angle, what we would need to do is we need to add we would need to add a little m. So I'm going to draw that up here. But measure, so if I asked you how to find how many degrees there are in your angle, you would see the measure of angle ABC. And that means I want you to find how many degrees it is. Okay, so the point where the rays of an angle or two sides of a polygon intersect, that's called your vertex. So just like in the picture above, your vertex would be B. So if you had an angle, and I called it DEF, your vertex is point E on that angle. Okay. Next, so two angles that have the same measure. So just like two segments that have the same measure, two angles that have the same measure are called congruent angles. And remember, with congruent segments, what we do is we put the tick marks to mark that they are congruent. When we have congruent angles, what we do is we draw in something called arcs. So arcs look like this. And if we have another set of congruent angles, we would just add more arcs on. Okay, so to say that these angles are congruent, we would say angle ABC is congruent to angle DEF. What that means is that they are the same, essentially the same angle. And if we wanted to say that they're equal, we would say the measure of angle ABC is equal to the measure of angle DEF, and that means that they have the same number of degrees. A geometric figure that divides an angle into two congruent parts. So instead of a segment bisector, this is an angle bisector. So you would see something like this. So you have a ray, ray BD, and then you see the arcs of angle ABD and angle DBC congruent. So what that means is that ray BD is an angle bisector. It cuts the whole angle into two congruent pieces. Just a real quick thought, bisect means to cut into two equal pieces. Trisect would mean to cut into three equal pieces. An angle between 0 degrees and 90 degrees, that's an acute angle. I'm actually not going to do a diagram or a notation for that. A 90-degree angle is a right angle, and I will do a diagram for that. As for an acute angle, there's no way to really show that it's in between 0 and 90 degrees. An acute angle cannot be 0 degrees because that's not an angle. An acute angle cannot be 90 degrees because that's a right angle. A right angle looks like this. Now we cannot assume that this is a right angle. What you need to see in order for this to be a right angle is this little square box. That will tell you that this is a right angle. Okay, so I'm not going to do a notation for that. An angle in between 90 degrees and 180 degrees is an obtuse angle. There is no way to show this in picture form or notation wise, but an obtuse angle cannot be 90 because that's a right angle. And an obtuse angle cannot be 180 degrees because that's a straight line or a straight angle. A 180 degree angle is a straight angle. Or also you could say it's a straight line. And so with this, your picture would look like this. Now this is you cannot assume anything in geometry, but this is the only thing that you can assume in geometry, is if something looks like a straight line, it is a straight line. That's the only thing that you guys will be allowed to assume this year. Otherwise, if I give you something that looks like this, we cannot assume that it's a right angle unless we have that square on the angle. And I'm not going to give you a notation for a 180 degree angle. Two angles whose measures have a sum of 90 degrees. That is, I almost put the wrong one, I'm sorry. That is complementary angles. Complementary angles can be connected to one another, so you could have something that looks like this, where we have a 90-degree angle, and then like maybe that 90-degree angle is split. So these two angles are complementary, or they can be completely separate. So something like this angle being, let's say, 30 degrees, and this angle being 60 degrees. Those would be complementary angles because they sum to 90. I'm not going to give you a notation for that. Two angles whose measures have a sum of 180, that's supplementary. So supplementary starts with the letter S, and so does the word straight. And we know a straight angle is 180 degrees. So that's a way that you can remember it, is S stands for straight, and supplementary. So it means that it has a sum of 180. So again, just like complementary, they can be connected to one another. So maybe you have a straight line and you have a ray going through that straight line. So it creates two angles that add to 180. Or you could have something where one of your angles, let's say, is 30 degrees. And the angles are separated, and then you have another angle that's 150 degrees, and their sum is 180, and so those would be supplementary angles. I am not going to give you notation for that as well. All right, moving on. So now, two angles that share a common vertex and a common side. So what this looks like is we have something like this, where we have this angle and we have this angle. And both of them have the same vertex and one side that they share. These are called adjacent angles. Adjacent means that these angles are right next to one another. I'm not going to give you a notation for that. Two adjacent angles whose sum is 180. So what that would look like is we have a straight line and a ray going through that straight line. And so I have this angle here, and I have this adjacent angle here, and both those angles together form a straight line. While that would be supplementary angles, that's not what I'm looking for here. For this one, that's called a linear pair. Linear means line, so straight line. Pair means two. So we have two angles that make a straight line. The non-adjacent angles formed by two intersecting lines. So we have two intersecting lines, and not the angles right next to one another, but the ones across from one another. Those are called vertical angles. Vertical angles create two V shapes. So this is a V, and then right across from it, this is also a V. Lines that do not intersect, lines in the same plane that do not intersect. Those are parallel lines. So what I mean by this is if I had a cube, you're going to do your best to draw a cube right now. These two lines lie in that same plane, the top plane, but they do not intersect and they will never intersect. Those are parallel lines. And with parallel lines, you will see little arrows drawn on the lines, and that means that they're parallel. And you would see, so I'm gonna call this, I'm gonna give you a notation here. I didn't give you a notation for the last couple. But for this one, I'm going to give you a notation. So you would say that segment AB is parallel, so parallel is just you draw two parallel lines, to segment CD. Lines that intersect to form 90-degree angles, these are perpendicular lines. So if I had two lines intersecting, right now I cannot assume that they're perpendicular. But as soon as I put this right angle in, that means that they're perpendicular lines. That's what that would state, that right angle. And we would say that line AB, and then for the symbol for perpendicular, it's kind of like an upside down T. That means perpendicular, so line AB is perpendicular to line CD. Lines that do not intersect in the same plane, those are called skew lines. Or sorry, they do not intersect and they're not in the same plane. I apologize. So let's draw that cube again. This will be the last one before we move on to another video to do the rest of the vocab words here. Okay, this line and this line are not in the same plane. They will not intersect. They are skew. There is no notation for skew lines. All right, continue on in part 2.